It's a wonderful morning here. I hope you're all having a great morning as well. I am Mr. Ish. In this video, we're looking here at this definite integral. It represents a rational function x cubed minus 1 divided by x cubed minus x squared. If you were to graph it out in just a very rough manner, you would have a graph which would look something like that, and then it would proceed in this direction with the x equals 0, your y-axis being a good vertical asymptote. And that right there would be a graph. If you're looking here from 1 to 2, 1 could be here, 2 could be here, and you're looking at this portion right here. But you can always look at this in terms of a graphing software and get a better depiction. But this right here represents the rough approximation of what we're looking at. The best way to proceed with any rational function is always to simplify it, because some things might cancel out and your initial expression will become easy. It's x minus 1 and x squared plus x plus 1. Over here in the denominator, you can isolate. You have a x squared, you have a x minus 1. You can cancel these out, and when you cancel them out, your expression becomes x squared plus x plus 1 divided by x squared dx. Now, it wouldn't be a bad idea to separate everything in their individual denominators. You'd be looking at something like this: x squared over x squared plus x over x squared plus 1 over x squared dx. And that right there would lead you to your antiderivative. When you simplify this, you're looking here at 1 plus 1 over x plus 1 over x squared dx. And now in this last step, let's bring in the antiderivatives. The antiderivative of this 1 would just be an x. For 1 over x would be a natural log x. And then for 1 over x squared, well, you're looking here at an x minus 2. You do plus 1 over minus 2 plus 1. You'd have a minus 1 over x. So that's what we have to bring. A minus 1 over x, and everything here 2 to 1. But the best way to do this definite integral part is to do each individually. When you're looking here, you're doing 2 and 1, and the difference of the 2, you'll get 1 from right there. When you're looking right here, you'll do natural log 2 minus natural log 1, and then from here you'll do 1 over 2 minus 1 over 1. And that right there is going to lead you finally to this answer that we want. You have a 1. From here, this is just a natural log 2, because natural log 1 is a 0. You'll have a natural log 2. You have a half minus a 1, which is a minus half. Minus half hits with this minus and becomes a positive half. So when you do the final simplification, you're looking at 3 over 2 plus natural log 2, and that right there is your final answer. If you want, you can get a good calculator value. You'll do 1.5 plus natural log 2. You'll have 2.193. 2.193 would have represented that area below the curve which I showed you very early on in this video. And this right here was the exercise for this specific video right here. Short, sweet, simple, and to the point definite integral rational function, easily handled after you've simplified it. And that's the end of this presentation. You all have a great day. Bye.